Hi, my name is Anders. In this chapter we're going to look at the workflow in 3D printing. In this chapter we're going to look at CAD models and formats that can be used for 3D printing. We're going to look at build preparation and support generation. Then we will cover build simulation of the process. We're going to look at the printing process itself. And finally we have post-processing. First of all, we need a 3D model of the part that we would like to print. We will make that in some kind of CAD program. For industrial use, you will typically use programs as SolidWorks or CATIA. These programs use parametric modeling, where it is easy to go back and make changes, but also easy to make new changes. Some of the common formats for these programs are either STEP or Parasolid X_T. For non-industrial use, the STL format is common. This is a dead format where it is more difficult to go back and make changes and make new changes. The STL format uses triangles to represent the model. This, however, makes it difficult to make rounded curves. In the future, the 3MF format could replace the STL format and solve some of the issues. If we proceed to the build preparation, it is different for the different technologies. Here we see the 7 main AM technologies. We will focus on some of the differences in the next couple of slides. First, we will look at the build preparation for laser powder bed fusion, FDM and SLA, which is quite similar. First, the CAD model is imported in the job preparation software. This could, for instance, be Materialise Magics. Next, we need to orient our part in the printer. This is typically a compromise between getting high level of details, but also printing as many as possible parts in each build. Finally, the support structure should be applied to the part, which ensure that the part is attached to the platform during the printing. Keep in mind that the support structure should also be easy to remove after the printing. You can find more information about the build preparation at the Materialise Magics website. Next, we will look at build preparation for material jetting and SLS, which is slightly different. Here, parts can be nested in 3 dimensions within the build chamber, and support structure is not needed. When you don't need support structure, you have greater design freedom compared to other print technologies. Just be aware that you should be able to remove powder from channels and cavities after printing. Before printing, you can simulate the whole printing process. You do this to predict and avoid failure during printing and to estimate geometrical distortion, and you can even use it to compensate for the distortion. Build simulation is often used for laser powder bed fusion and metal binder jetting, but also in some cases for FDM and SLS. After printing, we need post-treatment. Here are some examples of initial post-treatment. For FDM and SLA, you use screwdriver and grippers to remove the support structure. For SLM and E-beam, the 2 metal technologies, you first need a furnace to remove residual stresses. Then you need an angle grinder or grippers to remove the support structure, which is more difficult to remove compared to FDM and SLA. For SLS and the jetting technologies, we don't have support, but the powder is more difficult to remove. Here we use a compressor to blow away loose powder, and we can also use piano wire to remove powder from internal channels. Finally, we have surface finishing. For metal printing, we use more aggressive technologies. This could be abrasive blasting, where you typically use glass or corundum beads to even out the surface. It could also be deburring, where you use ceramic chips to grind the surface. For polymers, you can also use deburring. Furthermore, you can use chemical etching to seal and smoothen the surface. Finally, you can also color your parts. This is especially relevant for SLS parts. Finally, we have a video showing the entire workflow. In this case, it's laser powder bed fusion in metals. First, we are preparing the build job by finding the perfect orientation and adding support structure on the part. Next, we are printing the part layer by layer. After printing, we transfer the build cylinder to a powder removal station. Here we remove all the powder that is not used to print the part. After removing the powder, the parts need stress relief. This is typically done in a furnace. After stress relief, the parts are removed from the platform with a bandsaw, and the support structure is removed by hand. Finally, we have surface finishing. Here we use abrasive blasting and deburring.